Traditional naming of polyatomic ions. When we name polyatomic ions, chemistry uses a consistent set of historical or traditional rules and IUPAC systemic rules. These patterns will allow us to predict names from formulae and vice versa, which is an essential skill at this level. And most of the rules, they relate to oxygen-containing ions, or what we would otherwise call as oxyanions. The first, 8. When ions end in 8, this is the most common oxygen-containing ion. For example, nitrate, that has 3 oxygens, and sulfate has 4 oxygens. And this would be the most common form of a nitrogen and an oxygen containing ion. So NO3 1-, that's nitrate, sulfate, SO4 2-. ITE, that is for oxygen containing ions with 1 less oxygen than the 8 ion. So the 8 ion, ATE, that was the common form, but 1 less will end in ITE. So instead of nitrate with NO3 1-, it becomes nitrite, NO2 1-, and sulfite is SO3 2-, whereas the common one was sulfate, SO4 2-. Per will be used as a prefix for 1 more oxygen than the 8 ion. For example, perchlorate, ClO4 1-. Chlorate is the common one, and that is ClO3 1-, but 1 more than the common form, you add per as the prefix. Hypo, now it becomes even more confusing. That is the prefix when there's 1 less oxygen than the ite ion, because if you remember, ite was for ions 1 less than the 8 ion, and if you go 1 less than the ite ion, you're going to use the prefix hypo. So with hypochlorite, ClO2 1-, the 8th version of chlorate was ClO3 1-, so hypo is 1 less. If you have multiple versions of the first element, then the prefixes often take the form of di, tri, tetra. This is ancient Greek numbering, and examples of this would be dichromate. So di meaning the 2 chromions, and chromate is the oxyanion name. We also have dihydrogen phosphate. You can see 2 hydrogens, and there's the phosphate group. And that lastly takes us on to hydrogen. When we add hydrogen, that changes both the name and the charge. If we take carbonate, CO3 2-, when we add a hydrogen with its 1+ charge, it will give us hydrogen carbonate. So we've changed the name, we've put hydrogen in front, and we end up with HCO3, and the charge has changed because we've added that 1+ charge. So it's now 1-, which increased from the 2-. Do check the next video, it links very much to this, and thanks for watching. I'll see you next time.